Hello guys, in this video we're going to be seeing the question that is maximum subarray on LeetCode. So as you can see here, it's given that you are given an integer array nums, and we have to find the subarray which has the largest sum, and we have to return that sum. So in example 1, as you can see, the array has been given as this array, and the maximum subarray sum is given as 6. So like we have basically taken this subarray, that is 4 minus 1, 2 and 1, which is giving us the sum of 6. Now if you take any other subarray of any length from this specific array, that's always going to give a sum that is less than equal to this 6 over here. Okay, so that's for sure. So that's how we have to output the answer. Now this question is a really fundamental question if you are solving array based questions. So this is linked to a very popular algorithm known as Kadane's algorithm. So how do we approach this problem using Kadane's algorithm? So let's copy the same array that we have over here. So the array is -2, 1, -3, 4, -1, 2, 1, -5 and 4. Okay, so yeah, this is the array. So let's see how we're going to approach this using Kadane's algorithm. So what Kadane's algorithm basically does is that we have to have a variable which is storing the recurring sum. Like we will keep on iterating from the start of the array. Okay, we'll start from the index 0 and we'll keep on iterating from the start of the array, and we'll keep the recurring sum in a specific variable. Okay, so say at first we add -2 to this 0. Okay, so the sum now becomes -2 at first. Okay, so now what are we going to do? We will also have a like a global maximum variable in which we are going to store which is the global maximum sum that we have occurred, the global maximum subarray sum. Like this is going to be the recurring sum, right, in which we are going to add each and every index element. But we also need to keep an variable which is going to store the overall maximum subarray sum. So let's say we are taking that variable as maxi, and let's say we take the minimum value that an integer can hold in that. So now what we are going to do is that at every index, whenever we add that index element to our recurring sum, we're going to check if this recurring sum is actually greater than this maxi. Now if it is, then we are simply going to update the maxi to sum. Okay, if sum is greater than maxi, we are going to update the maxi to sum, because obviously our aim is to get the maximum subarray sum. So that's what we're going to do here. Now what if I say like here, say the like all the elements are negative over here. Okay, so in that case there can be two possibilities, right? Like if say in the question we have been given that empty subarrays are also allowed. Okay, in that case we can simply return the sum as 0 itself. Okay, we can simply return the sum as 0 itself, because the sum of an empty subarray is always going to be 0. So that's why we are like it will not get updated at any point of time, and it's always going to stay 0 itself. Okay, done. So now what if empty subarrays are not allowed? If empty subarrays are not allowed, in that case we have to have at least one element. So in that case, if all the elements are negative in the array, in that case we are going to have the least negative element as our answer, as our sum, because obviously if you add on one more negative number to that number, then obviously it's going to get even more negative in value, right? So that's we don't really want that. We want the maximum subarray sum. So that one least negative number is going to be our answer. Now here also, as you can see, the sum here is -2, right, after adding the first element. Now what was sum's initial value? The sum's initial value was 0, right? Now when we add -2 to it, it becomes this. Now for the maxi, we initialized it by int min. So -2 is obviously going to be greater than int min. So our maxi is going to store -2 at first. Okay, now say like this was when we were at index 0. Now say when we reach index 1, so the sum is now going to be like one more thing that I would like to say, that like here, as we can see, our sum is negative in value, right? Negative in value. So what do you think? as I mentioned, that if all the elements of the array are negative in value, in that case, we don't really want to add any other negative element from the array, right? Because that will only increase the negative value of the number, right? So we will avoid adding any more negative element at that point of time. So, right? So what we'll simply do here to avoid that is, if we encounter a negative sum, we are going to reset the sum to 0 after doing this, like after updating it with the maximum like global variable. Now I will tell you that why are we resetting it to 0 after comparing. That I will tell you in a later part. So what we're going to do is, if we see that the recurring sum has become negative in value, we will immediately reset it to 0, right? We will reset the sum to 0 as we had initialized it in the starting of the iteration. So now next up, like we have the sum as 0. Now we'll add the next element, that is at index 1. We will add it. Now the sum becomes 1, right? Now the maximum right now holds -2, right? Maximum right now holds the value of -2. Now right now the sum is 1, recurring sum is 1. So what we compare is if 1 is greater than -2, obviously it is greater than, so maxi will get updated to 1. All right, done. So next at index 2, we reach at index 2, right? We reach at index 2. Now sum becomes, now see, when the sum is already positive, okay, now we have hope now, right? We have hope that in the future, if we encounter whether a positive or a negative element, this positive recurring sum is going to act is going to kind of act positively. It is going to act in our favor, because if it's a negative recurring sum, then even if it gets added to any positive integer in the future, in that case also it is only going to degrade its value, right? It's going to degrade the overall sum. So we don't want that. Since we want to maximize the recurring sum, we are going to reset it whenever the value of recurring sum goes into negative. So now if we have the value of sum as a positive itself, we know that it is always going to have a positive effect, even if the element in the future is negative or positive. So we are going to retain it. Okay, here we're going to retain it as 1. So in the next step, the sum added, or the element added, is -3, right? So it is -2. The sum becomes -2. So the clear example you can see here, if say we had kept the sum is equal to -2 without resetting it in the first step, in that case what would have happened is, in the next step, if the sum would have been added to like 1, this element, then the recurring sum would have been -1, right? In that case, see, the -2 sum that we retained over there, it is going to have a negative effect even if a positive number like 1 comes in the future, right? So now see, if we didn't consider that negative recurring sum, which was -2, in that case our sum was coming to be 1 here, right? But if we considered that recurring one as negative value, in that case our sum in the step 2 in the index 1, it was going to be -1, right, which is lesser than 1. So obviously we can say that like the step that we are doing, that whenever our recurring sum goes to negative value, we are going to reset the sum is equal to 0. So that is perfectly correct. Okay, so let's erase this over here. So now next, as we had we have seen that our like after adding -3 to our recurring sum, our result is -2. So is -2 greater than 1? Because our maxi now holds 1, right? Is -2 greater than 1? No. So we are not going to update our maxi. Our maxi is going to stay as 1 itself, right? Okay, done. But again, the sum has become negative over here. So we are going to reset it to 0. Okay, we're going to reset the recurring sum to 0. Okay, now let's go to the next step. At index is equal to 3, the element is 4, right? Element is 4. So sum is going to become 0 plus 4, that is 4. Now is 4 greater than 1? Yes, 4 is greater than 1. So maxi is going to be updated to 4. Perfect. So in the next step, we go to I is equal to 4. That is -1. Okay, -1. So sum becomes 4 plus minus 1, that becomes 3 again, right? So is 3 greater than 4? No. So maxi is not going to get updated. Maxi is going to stay as 4 itself. Now we go to index 5. When we go to index 5, it is 2, right? So now sum becomes 3 plus 2, that is equal to 5. Is 5 greater than 4? Yes, 5 is greater than 4. So maxi is going to be updated to 5. Perfect. Now next we go to the element minus 1 over here. So again, at I is equal to 6, the sum is going to become 5 plus minus 1. Okay, so it is going to become 4. So is 4 greater than 5? No. So it's not going to get updated. Maxi is going to stay as 5 itself, right? Perfect. So and the next step again, sorry, I think the element was 1 over here, right? Yeah, it was only 1. I'm sorry, my bad. So it was only 1 over here. So after 5, if it it adds 1, then it's going to become 6, right? Is 6 greater than 5? Yes, it is greater than 5. So maxi is going to be updated as 6, right? Now at I is equal to 7, the element is minus 5, right? Sum is equal to minus 5, 6 plus minus 5, right? So it's going to become 1. Is 1 greater than 6? No. So it's not going to get updated. Maxi is going to stay as 6 itself. Now at I is equal to 8, I think it's the last element. So we're going to add 4 here, right? 1 plus 4. It's going to become 5. Is 5 greater than 6? No. So maxi is going to stay as 6 itself. So at the final step, our maxi is going to stay as 6, which is our answer also. Now, how did we do this? See, as I explained to you, that the simple steps that we need to follow in our Kadane's algorithm is that we need to have a recurring sum variable. Okay, recurring sum variable. Okay, recurring sum, we need to initialize it with 0. Okay, then what we're going to do is at every step, we're going to do that recurring sum plus equal to whatever whatever index, whatever element is present at that specific index. Now what we're going to do is we're going to compare our global sum with that current sum that we have occurred, okay, that we have encountered. So we did that. Then we check if our recurring sum is less than 0, then we reinitialize our recurring sum to 0. Now why do we do this specific step? As I explained to you, that if our recurring sum is negative in value, in that case in the future also, whatever positive value or negative value is there, this specific recurring sum is always going to cause a negative effect on that specific element, right? Or like whichever we are going to be adding in the future, because by taking this specific negative value recurring sum, it is going to only degrade the value of whatever subarray we are going to be considering in the future. So what we do is we simply want to avoid that, because we want to get the maximum value of sum of subarrays. So we want to reset the sum to 0 whenever a sum of less than 0 is encountered, right? So these are the 4 steps that you need to follow for solving this question using Kadane's algorithm. So let's jump to the code and check how this works. Yeah, so in our code, as we had mentioned, that we will be taking 2 variables at first. One will be our recurring sum, which will be initialized to 0 at first, and when we one will be our maximum sum variable, which is going to initialize to minimum value of integers, and it's going to be updated at every step. So we're going to run a loop from 0 to the last index of the array, and we are going to first add the array element at every index to our recurring sum. Then we are going to see if we can simply just update our maxi using the max function. So we'll see this is going to store the maximum variable, the maximum value in between sum and maxi into maxi. And at the next step, as we had mentioned, that if recurring sum goes into negative value, then we are going to reset it to 0 itself. So at last we're going to return our maximum sum variable. So let's see if this code runs. So as you can see, the example test cases are successfully executed, and yeah, so the code has been submitted. So now what did I say? That here we are going to at first compare like which one is greater in between sum and maxi. Like we are going to update the maximum sum that we have till now, and only after that we are going to be reinitializing the sum to 0 if sum is less than 0. Now why are we doing that? Why can't we put this statement before? Right, why can't we put this statement before? Because like our aim was to kind of avoid wherever recurring sum becomes negative value, right? So why can't we do this step instead? See, if you do this, what will happen here is, let's go to this. If you do this, what's going to happen here is that whenever, say, you have all negative values in an array, okay, whenever you're going to have that, what is going to happen is that, say you have all negative values in an array like -1, -2, -3. Okay, let's take just 3 elements. In this case, we initialized our initial recurring sum to 0, right? And then we were we were having a maxi that was equal to int min, and we were doing that, right? So now if you like after adding, say, -1 to our sum, it becomes -1, right? So after doing that, like if you like directly see that if sum is less than 0, then you reinitialize the sum to 0. In that case, what happens is that you're not considering this subarray, right? Because as we had discussed earlier, like in the case when all the elements are negative in the array, in that case we are going to have the answer as the element that has the least negative value in the array, right? Which is here -1. The answer in this for this array is going to be -1, that single element, right? The sum, the maxi is going to stay as like it is supposed to stay as -1, right? But then here, as you can see, even before updating your maxi, which was the global maximum, even before like updating that, we are reinitializing the sum to 0, reinitializing it to 0. So in that case, what happens is like it would have been fine if like we also could have empty subarrays as our answer. In that case, if all the elements were negative, in that case we could just say that we are going to not consider any element from this array. We're going to just give an empty subarrays answer, and the sum of an empty subarray is always going to be 0. So in that case, our answer would have been perfectly correct if we would have written this this reinitializing of some line, this if sum less than 0, some is equal to 0. If we had written this line even before updating our global maximum, this would have been perfectly fine if empty subarrays would also be an answer. But here empty subarrays are not allowed, okay? So what we have to do is we have to take at least one element, and for doing that itself we have to first update our maxi, because even if it is one element, it needs to the maxi like if in case of all negative elements, maxi needs to store the value of the maximum out of all those. That means that the least negative value out of all those, right? So that's why we write it in this manner only, right? So this is all about it. So as you can see, this is a simple like 4-step process, as I told you over here, Kadane's algorithm. You can do it using this concept itself. Now the thing is that you might have heard at a lot of places that this question can be done using DP. So you might be thinking that the approach of DP is very much different from this specific approach. I would like to tell you that it is conceptually, or you can say it is fundamentally not very much different from this specific approach. Actually, it is quite similar to this approach itself. Now what we do in DP also is same kind of thing also, only we maintain a recurring sum variable that is initialized to 0, and we also maintain this global maximum. At every step we will simply update our sum to the maximum between the current element, the current index element, and the like already what sum is there plus that current element. Okay, we simply do this, and then the maximum the global maximum updating step is the same only. So why do we do this over here? See, in the earlier case, what we were doing is that we were first, adding our element to our recurring sum variable, and then we were checking, like we were updating the maxi, and then we were checking if it was less than 0. Now we are combining 2 steps into this 1 step over here. Okay, so say we have all negative elements array also. In that case also, we are comparing the current element with the sum plus the current element. So if say all negative elements are present, so it is always going to consider the least negative element in our sum, right? Because obviously if you add negative element to another negative element, in that case it's only going to become like more negative in value, right? So we won't hold that into sum. It would automatically take the least negative value into the sum, and it will update it into maxi. And even if there are like mixed numbers, in that case also, this step basically combines 2 steps that we did in our Kadane's algorithm, right? So since Kadane's algorithm already has a predefined set of steps, so that's why some people refer this specific approach to be like a dynamic programming approach. Now, if you visualize this approach from the DP perspective, whatever subarray we have considered till now, we are holding, the value for that specific subarray sum into our recurring sum variable. So say we are currently at index I is equal to 2. So, and the elements I is equal to 0 and I is equal to 1 have both been considered into our current subarray. So the sum of both I is equal to 0 and I is equal to 1 is going to be stored in our variable sum, right? So like whenever currently we are processing the operations for I is equal to 2, we already have the pre-computed value of the sum of I is equal to 0 and I is equal to 1, or like whatever indexes of variables we have considered into the subarray before the specific index, before the current index, we have that stored in our variable sum. So we are processing the current index operation using that specific sum that holds the recurring sum value that has occurred before that specific index. That is the exact part that DP plays over here. Okay, so I have explained you how to visualize this problem using the 4 steps of Kadane's algorithm, as well as I also told you how to visualize this problem from the DP perspective. So that's how you solve this question. This is a very fundamental question of arrays. A lot of questions where you need to calculate subarray sums, and you need to perform various different operations of this also, like you say you are to find the minimum subarray sum. Now in that case also, some variation of this question of this Kadane's algorithm is only going to be used. So you can try that out yourself. So yeah, that's all about this video. Now if you have any doubts, you can post it in the comment section. Thank you.